Hello, my name is Michelle Samaras, and in this video we will talk about why oil and water don't mix by comparing their chemical properties. We will also show experimental clips demonstrating what happens when you try to mix these two liquids together. First, we will talk about polarity. Polarity refers to the way atoms bond with one another by sharing their electrons. A molecule will become polar if there is an atom or functional group that has a stronger attractive force on the electrons. This would cause the electrons to get drawn towards the atom or group, thus making a slight charge imbalance. In this case, a water molecule is polar due to the oxygen atom pulling on the electrons, giving the hydrogen atoms a partial positive charge. Oil, on the other hand, is nonpolar. The carbon chain is held by covalent bonds, meaning the electrons are shared among the molecule. Since the oil molecule is nonpolar, it is considered to be hydrophobic, or a water-fearing molecule. Water molecules are strongly attracted to each other due to the hydrogen bonds between the atoms, making it hard for the oil to interact with the water molecules. Another property to talk about is density. Density is the measurement of how much material there is in a certain amount of space. Given by the equation, density equals mass over volume, with units being grams per cubic centimeter. The density of water is approximately 1 gram per cubic centimeter, while oil has a density of 0.93 grams per cubic centimeter. When mixing two liquids together, the one with the heavier density will be on the bottom, while the lighter density will be on top. So when comparing these values, we should see oil on top of water due to the lower density value. Show what happens when you pour oil into a container of water. For safety purposes, we need gloves, lab coat, and goggles. Now we are ready to go. So we have two beakers here. One is labeled with water, with food coloring, and the other with just oil. So we're going to pour the water into the middle beaker first, and then we are going to grab the oil and pour it into the same beaker. And we will see what will happen if you try to mix oil and water. As you see, we have water on the bottom and we have oil on the top because the density of the oil is lighter, so that means the oil is going to be on top of the water. Let's pour the last bit of water and oil together to get a closer look. As you can see, the oil and water still separate like before, but there are some bubbles mixed into the water due to the motion of the oil pouring into the beaker. To get water and oil to mix, you need to do two things. One, shake the container to get the oil to separate itself to form little bubbles to interact with the water molecules and to add an emulsifier, a compound that has both polar and nonpolar properties to get these two molecules to interact. An emulsifier can be as simple as soap, which allows us to clean oil out of these beakers since water alone cannot be able to remove the oil off of the glass. Let's review what we've gone over. Polarity is about the electrons and whether or not they are shared equally within the molecule. Water is polar due to the oxygen atom pulling on the electrons, giving the hydrogens a partial positive charge. With polarity, remember likes dissolve likes. Polar molecules dissolve other polar molecules and vice versa with nonpolar. Density is the measurement of mass per amount of volume. Water has a higher density than oil per cubic centimeter since we saw that oil does float on top of water. To get these two to mix, you will have to add motion to the system through shaking or stirring, along with adding an emulsifier that carries both polar and nonpolar properties. Thank you.